So first basic thing you need to know about this is that ground speed equals airspeed plus wind speed. So in this case, we know the airspeed and we know the wind. Ooh, this is worded very oddly. So we know the ground speed. So let's draw out the ground speed, or sorry, airspeed. So here's airspeed. It's the plane's headed north 40 degrees to the east. So if I draw in north and then 40 degrees to the east, that's the direction that it's headed. And it's going 700 miles per hour. So we can figure out the north component and the east component from this. This side is adjacent, so that would be cosine. This side is opposite the 40, so that would be sine. Make sure you are in degrees when you type it in. So we're going to do 700 cosine 40. $536.231. And that's in the northern direction, so I'm just going to put a little n next to it. And then we have this east direction of 700 sine 40. Which is 449.951. And that's in the east direction. So next we're going to take a look at the wind, which is blowing, here's the tricky part, from the southeast. So if it's from the southeast, wrong direction. So if it's blowing from the southeast at 80 miles per hour, here's south, here's east. This is where it's blowing from, so it's blowing this way, which means it's actually blowing north and west. The direction of that is actually going to the north and west because it's coming from the south and the east. So it's backwards because that's where it's coming from, blowing north and west at 80 miles per hour. So since it was not specific, we're actually just going to assume the 45-degree angle there. So the hypotenuse is 80, so that means we can find our northern component and our west component adjacent, so that would be cosine times 80. And then this is opposite, so that's going to be sine. And then you know that sine and cosine are the same, so those will be the same values. It's square root of 2 over 2, which means this is 40 square root of 2, and this is 40 square root of 2. That's in the north direction, and this is in the west direction. And 40 square root of 2 west. So if you're putting these together to get our ground speed, north and north, those are going to add to each other. East and west, those are going to be subtracting from each other because they're fighting each other. They're going opposite directions. Subtract it because it's west. It's going the opposite direction. However, the east direction, the east component is larger than the west, so that means our result will still be going east. The wind isn't blowing us far enough that we're going to turn around and go the wrong direction. So 536.231 plus 40 square root of 2. That's our north component now, the 592.8. Still heading north. And then 449.951. And this time we subtract the 40 root 2 because it's the opposite direction. 393.382. Still heading in the east direction because we had more east than we did west. So that means that our ground speed is heading to the north and to the east. North 592.8 and east 393.382. And north and east makes a 90-degree angle. So we can find the hypotenuse, which is the magnitude or the actual ground speed, by doing Pythagorean theorem. The 592.8 squared plus the 393.382 squared so we can do answer squared plus the 592 point, let's round that to 8 like we did before, squared. That equals the hypotenuse squared, so square root that. So you get 711.45 miles per hour. So that's the ground speed. We don't have the direction yet. We have to figure out this little angle right there, which comes from tangent, opposite over adjacent. So we'll do the 393 over the 592 and type that into an arctangent. So our angle there is 33.57 degrees. And when we turn that back to a bearing, we're going north and then that many degrees to the east. So it is starting from the north, go 33.57 degrees towards the east. So there's our speed and there's the direction.